Alright guys, we are beginning Unit 2. Hooray! So we're going to do a little introduction activity here to kind of get you guys warmed up for what we're going to be learning in Unit 2. Unit 2 is about something called integrals. And what integrals do is they help us find area under the curve of a line. Okay? So for instance, if I were to ask you guys to tell me what's the area under this curve, and this thing that we call an integral, which looks like this, will tell me the answer. Cool. All right. Why that works, we will not be explaining that. There's a reason it works, and it's quite a complicated explanation, but we won't be going into that. Just want you guys to know that it does tell you the area under the curve, and we're going to do a little warm-up activity to kind of get you guys ready for the lesson. So what I'm going to do in this little video here, I just want to help you guys do number 1, and that way you guys can do the rest of the problems on your own. Don't forget, by the way, when you're done with 1 through 4, there is a part 2 down here. It's kind of easy to miss because it's so small, but that's actually very important. Make sure you guys do part 2 there. Let's go ahead and begin. So I will do number 1, and then I'll let you guys check out the rest on your own. Okay. So we have a curve, which is this blue line here, and we're going to call that, I guess, we can call it, well, it's not blue anymore, is it? Just made it brown. But we'll call it y, okay, and there it is. That's the equation of that line. The equation of that line is y equals 4 minus x squared. Now what I want to do is I want to estimate, or approximate, the area under the curve. Now, we don't know how to do that. That's a weird looking shape, and we don't have any geometry to help us with that. So what we're going to do is we're going to estimate the area using rectangles. Okay? There's a couple of ways to do that. One way is with rectangles that go a little bit over the curve. The other way is with rectangles that go a little bit under the curve, like on number 2. And then number 3, I use even more rectangles. And then number 4, I'll let you guys answer that when it comes to that time for you to look at it. But for now, I'm going to show you guys how to get the answer to number 1. So I'll let you guys do 2 and 3 and 4, and then part 2 on your own, okay? So estimate the area under the curve below using the rectangles given, and the fact that the equation of the curve is this. Okay, so why do you need to know the equation? Well, you'll see as we go. So how do you find the area of a rectangle? Well, to find the area of a rectangle, you need to do the base times the height. Okay, so my base is 0.5. My height is 4. So 4 times 0.5 is 2. So the area of this rectangle here is 2. Now, for the next rectangle, though, we run into a little bit of a problem. I still can see what the base is. The base is also 0.5. But the problem is I don't know what the height is. Now some of you guys think, well, let's just estimate it. Well, you could, and that wouldn't be a terrible thing to do. But the height of this rectangle, I want you guys to know something about this. The height of this rectangle touches the curve right there at that point, where x is 0.5. I wonder, is there a way I can find the y value of that point if I know that the x value is 0.5? Because if I know that y value, then I know the height of my rectangle. Okay? Well, it turns out there is. I've given you an equation. You can find the y value if you know the x by just plugging it in. So the height of this rectangle is 3.75. So if the height of that rectangle is 3.75, then height, which is 3.75, times base, 0.5, is going to be, I don't know. I don't want to figure it out. I'm going to use a calculator, sorry. So 3.75 times 0.5 is 1.875. And in AP Calculus, we always round to the thousandths place, which is where this number ends anyway. All right, so now I'm going to repeat that process here. Height times base, right? Base times height. The base is still 0.5. And this is one where you can kind of tell by looking that the height of the rectangle is 3. So 3 times that, that's going to be 1.5. The last one, though, we have to do that little thing with the equation again. I see the base is 0.5. Let me write the last answer real quick. I see the base of this last little rectangle is still 0.5, but the height I don't know. And it's the height of the rectangle touches the curve right there when the x value is 1.5. So when x is 1.5, what's the y value? Well, we have to plug it in once again over here to figure that out. So the purpose of me giving you the equation, just so you guys know, is so you can calculate the height of the rectangle if you need to. The y value represents the height. So we have y equals 4 minus 1.5 squared. Let's see, 4 minus 2 is 2, minus an additional 0.25 is 1.75. So the height of this rectangle would be 1.75 then. So base times height, 0.5 times 1.75 would be 0.875. 0.875. So I found the area of each rectangle now. So if I go through and add all these rectangle areas together, that will tell me an estimate of the area under my curve. It's going to be a little bit of an overestimate because you guys see we have some extra area up here. So when I find the area of these rectangles, I end up with an area that's close to the area under the curve, but it's a little bit more than the actual area under the curve. But that's the business of estimating. You don't get it exactly right, you get close. So I'm going to go ahead and type in all these numbers. 2 plus 1.875 plus 1.5 plus 0.875, and I end up with a final answer of 6.25. So the area is approximately 6.25, and we know that the actual area is actually going to be less than that because these rectangles are slightly higher than the curve, so we're getting a little bit of extra area. Now when you guys do number 2, you're getting an estimate also, but it just so happens that yours is going to be an underestimate because the rectangles are under the curve. So if we know what the upper boundary is and we know what the lower boundary is, we can maybe get a better guess about what the actual area is, right? Just so you guys know, you need to know the heights of your rectangles here, right? And to do that, you need to find the y values of these points because the y values tell you what the height is. But other than that, I'm going to go and let you guys do the rest from here. So good luck, and we'll see you for our lesson 2.1.